This video is for lesson 24-3 about tangent segments. Learning goals are to prove that tangent segments to a circle from a point outside the circle are congruent and use that fact to solve problems. So here's our theorem for this lesson. The tangent segments to a circle from a point outside the circle are congruent. So we have this vocabulary word in here, tangent segments. 2 days ago we learned the word tangent. A tangent was a line that touched the circle in exactly one point. So what do you think a tangent segment is? That's going to be a segment outside the circle that touches the circle in exactly one point. Here's a drawing for us to look at. We have a circle. The center of the circle is point A. There is a point outside the circle, point D, and that point is connected to a point on the circle here at B. This segment is called a tangent segment. There's another tangent segment shown going from D to C. What this theorem is saying is that these two segments are congruent. Like if this was 10 units long, then this one was 10 units long as well. To prove that this is true, we could use some of our recent theorems about circles and segments. Remember that when you connect the center of the circle to the point of tangency, it's a 90-degree angle. The center to this point of tangency is also a 90-degree angle. Then let's connect from the center out to point D. Do you see two triangles? Do they look congruent to you? If the triangles are congruent, then these other sides must be congruent. This theorem allows us to solve problems involving circles. Here's an example problem number 2. In the diagram, RT is 12. So from R all the way to T is 12 units. RH is 5. So if this is 5 and the entire distance was 12, then HT is 7. MT is 21. So from M all the way to the T is 21. Determine the length of segment RM. So how long is this other segment going from there to there? To find that, we can use the theorem from today. Let's look at point T. Notice how point T connects to point H and to point A. Those are tangent segments, therefore they are congruent. If TH is 7, then TA is 7. Now let's look at point R. Notice how point R touches at H and it touches at D. Those are tangent segments. So if RH is 5, then RD is 5. Now look over here at point M. Notice that from M all the way to T is 21, and then this portion is 7. So how far is it from M to A? It's 14, because 14 and 7 would be 21. Then, if that's 14, how far is it from M to D? Those are tangent segments. They're congruent, so that's 14. Now we know the two parts that we need to find RM. RM is 19 units long. See, we were able to solve another problem involving circle because we know some theorems that involve chords and tangents and lines around a circle. Let's use this same drawing but change some of the information up and answer question B. So I'm going to erase all the stuff that had to do with question A. In question B, if OH is 4, so this distance here, let's label 4, determine the length of OT. So how long is it from O all the way to T? Well, we can find this using some of the theorems that we've learned about chords. First of all, the radius of the circle will touch point H at a 90-degree angle. Now we have a right triangle. Remember that we were told to begin with that RT was 12, that RH was 5, and we had found that HT was 7. How could you find OT? So with the Pythagorean theorem, we can say 4 squared plus 7 squared is equal to OT squared. This means that 65 is equal to OT squared, and OT is the square root of 65. In this lesson, we learned one more theorem that involved lines and segments drawn near a circle. Our theorem involved having a circle and from a dot somewhere outside of the circle, drawing two tangent segments. So touching here and then going like there and touching there. These tangent segments are equal to each other.